Here's the scenario. We get a used Mad Dog 50, a Gen 1. So this will be for the Gen 1. You can get the 50 Gen 1, get one with the blown motor, you can probably get it for 50 bucks. Make an e-bike out of it. Take off this, you're gonna take off this, and the shocks. Leave the carb hooked up, just take the cable off, disconnect the fuel line, take the gas tank off. Easy enough. We'll disconnect the wire to the stator, the pulse, and the CDI wire. Leave those with the engine. Disconnect your starter wire. If you have that one that bolts together here, which most of them do. If not, you have to pull it off the starter and take it off right there. Disconnect the automatic choke wire. We'll leave it hooked to the motor. We're gonna leave all these tail lights, headlights, blinkers, things like that hooked up. Don't forget to take your brake cable off. The ground cable. Take 2 with ground cable disconnected. Take 3, starter cable disconnected. So I separated the whole engine. There it is. It's as little as you can take apart and separate it. I'll just lay that off in the corner. But preferably you bought a dead Mad Dog with a blown engine. Toss that in the trash. There's your e-bike, ready to happen. We'll get rid of that gas tank. I might as well leave all the wiring bundle connected and just zip tie it up. You're probably wondering why Generation 1 Mad Dog 50, because it's the only Mad Dog with this. This is a key part of this e-bike, or these two things that hang down. So the swing arm comes in 100 pieces. It's not all put together like it shows. It looks pretty easy, but there's no instructions. Not sure what these do.
This is the rear end all the cool kids are using. This seems to be the setup everyone likes, is that AliExpress swing arm with the hub motor on it. I hope it's going to be better than the mid-drive option. It seems like what all these fast guys are using.
This swing arm is obviously way too long, but I bought the longest one. It comes in 3 different sizes. It comes in a short one that was too short. It comes in a medium one that was about 1 inch shorter than where the original wheel was. And then it comes in this super long one. I figured I could just cut the long one off to the length I want. These are just aluminum tubes, and that's my plan. But I would probably get the medium one and just have the wheel be 1 inch shorter if I wasn't going to cut them off. These tubes are held onto these brackets by these little set screws. I mean, they're big, I guess, but it just goes right there. They don't go into anything. So you've got 3 set screws here, 3 here, and 3 underneath. I just can't imagine that's enough to hold this tube safely on this bracket. The bracket seems pretty well made. I just threw this front tire on here to try to get an idea how high it is. But I can't imagine tightening that down is going to hold that tube in place. I'm probably going to drill a hole through here and mount a bolt all the way through there on each bracket, front and rear. The stock engine was being held in place with this brace here and this swing arm looking thing that was held on with a 10mm axle. So here's that 10mm axle. These things do look strong enough to hold the swing arm, and they do seem pretty significant. This swing arm is designed for a 12mm axle. To use this axle, the hole is 12mm, so it's too wobbly. The bearing that goes inside here is a 6201. See, the axle's too small in diameter for that. It would just wobble around. That wouldn't work. The 6201 bearing is 32mm outside, 12mm inside. You can get a bearing that's 10mm inside, but it'll be too little on the outside also, so it'll flop around inside here. They make these things called bearing reducers. 10mm inside, 12mm outside. So they fit inside the bearing like this. Like that. Now, the axle will fit through here fine, and it holds perfect. It's the right size, no play. The bearing is 10mm wide. The problem is this hole here is about 7mm wide. What could happen is that bearing sleeve could slide out of the bearing like this, and it could slide into that hole and lose contact like that with the bearing and just be wobbling around on the axle. So now we have the same problem. We have a loose axle and a loose bearing. We're going to have a spacer in here, and we're going to have a spacer going between here and the mount on the frame. We can't allow this bearing sleeve to flop around inside that hole. I also don't like these bearings. Pretty poorly made. So I'm going to go ahead and get a couple of good bearings that are 6201 size to put in here. They'll have a little bit more lateral support. You can kind of feel these things wobble. For a bearing to work properly, this part and this part can't be touching the 2 different parts that need to rotate. So the axle would stay put and the swing arm would roll around it. If you were to put the bearing on a piece of metal like this, it would never work because it's touching the inside and the outside. There's no rotation. That centerpiece has to be bigger than this centerpiece, and something has to press against it. It's impossible for this swing arm to work right because this bearing contacts the surface on the inside and the outside. What you end up with is the center of the bearing staying put with the swing arm. So now this is rotating around the axle, rotating the axle with it. Either way, it's going to create wear on the axle, or the whole swing arm would rotate around this, and that would create wear on the swing arm and wobble this out. So it's no good. No bueno. Now I'm going to add a washer in here as a backing plate. Pretty interesting, huh? And that will ensure it only contacts the center part of this bearing, and the washer fits the 10mm axle so that bushing will not fall out because it's 12mm around. The bearing won't sit in all the way because it'll stick up a little bit now. And I'm actually not going to use these big old fat washers. I'm going to use these little shims. They're pretty tiny, but they're really thin. It's just enough to keep that bearing from rubbing on the outside, and also little enough that it goes around the 10mm bolt and will hold the bearing reducer sleeve in. So there you can see the bearing and the reducer sleeve in there. This will go over top of it and just engage the inner part of that bearing so the outer part of the bearing can spin around without rubbing against the inside of that swing arm right there. It's a poor design, but it's the best I could find. This spacer will contact the other inside and not the outside, and then it should rotate around the axle. The other problem is the swing arm is hitting the frame right now. So this is the lowest the bike can go, which would be the most compressed the shock is. And it actually looks about level. So I'd want the swing arm to be able to go higher. Typically a shock mounted somewhere in here, going up to here, is going to move about 1.5 inches or 2 inches at this point. So it'll be a lot more in the back. Now if I slide the shock mount back more, it'll limit the travel. Of course, the further back I mount it, the more limited the travel is. There's less of a fulcrum effect back here. So obviously if we got it all the way back here where the original shock was, 2 inches of travel would only be that high. But if we get it up here, 2 inches of travel become like maybe 6 inches back here. So if that were the fully compressed shock, let's see what the fully extended shock would look like. I'll add 2 inches to this area in here. That's what 2 inches of travel at this point here look like. It looks pretty jacked up in the back, so that's probably going to be too high. So to get the swing arm to compress far enough to make it sit normal and still have clearance when it goes up, this may have to be cut away. But it's 25mm, and that's what we're looking for. The hole size is going to take a 10mm bolt. Now this on the stock Mad Dog is also a 10mm bolt, so that'll work out good. So you might find a shock you like that really matches your bike, you really like it, looks cool. You have quite a bit of adjustment actually. This bar here slides back and forth, so you could have that shock going out here to say 10 inches long. You could have it going as short as 5 inches long. So this will give you some adjustment when you slide it back and forth on the length of your shock. So I'm just going to get a ballpark. I'm probably going to try to get the shortest one I can find. So I'm looking at an eye-to-eye measurement of probably 6.5 inches. 6.5 measurement, that's a compressed spring. So that's going to be the eye-to-eye measurement minus this chrome part in there. So I'll find one 8.5 total length that compresses 2 inches, or maybe one that's 8 that compresses 1.5 inches. And that will give you my 6.5. I'll convert that to millimeters and start shopping. And when looking at shocks, the reason the stock Mad Dog shock is so darn stiff, it's a monoshock. It's designed for one shock. Well, they put it back here where there's no leverage. So it's just a really stiff spring. If this same spring were up here where you have leverage, like on a dirt bike, that spring would probably be real cushy and real bouncy. When you're back here, you're looking for like a 250 pound, what they call spring. And up here more, you're looking more like, 600, 500, 800, stuff in that range. Even 1,000 if you're a heavy rider.
And here's the perfect shock. This one looks cool. It's got the little remote reservoir with it. Looks more high-tech. Quality is 200mm, and that's good. Let's go look at the specs here. 30mm, so that means it's 170mm when it's compressed, and that works out to 6.7 inches, so that's perfect. The piston diameter is 14 millimeters. That's actually a little bit thicker than the Gen 4 and 5 single shock. The spring thickness is 11 millimeters. It's 1 millimeter thickness. It's 72 millimeters across. That's almost 12 millimeters bigger around. So it's going to look nice and beefy. It's got a loading of 450 kilograms or 1,000 pounds. That's excellent. The eye bushing is 10 millimeters. That's perfect. And look at there, the eye thickness is 25 millimeters. That's the size we're looking for. This is the perfect shock. Boy, is it expensive.
I forgot to mention these spacers I put in the swing arm here. So I have one on each side. I ordered mine too big around. I don't know, I made a mistake. I ordered mine 30 millimeters big. I wouldn't get them bigger than 25 millimeters or they'll hit the outside of the bearing like mine did. But the inside hole is 10 millimeters, so an M10 bolt can fit in it. The outside's 25 millimeters, maybe smaller, whatever you want. And the length on the two outside ones, I have 19 millimeters each, so 19 and 19. And the inside ones, I have two 50 millimeter ones and a 36 millimeter one between them, just to make up this whole distance. I'm going to take this outside edge off here with this Dremel, just to be sure that doesn't contact the outside of that bearing. In hindsight, 29 or 30 millimeter spacer was probably too big around. Big spacers look cool, but I would go with probably no bigger than a 25 millimeter spacer, so it wouldn't contact the outside of this bearing. You can find spacers like this made out of aluminum on eBay, Amazon, on AliExpress. There's all sorts of places that you can find them already cut. You can also get them custom cut to the right size you need, but I found it cheaper if you just order the sizes they have. Much better. That's a good looking shock. It's got this cool reservoir on it, some adjustments on it. Looks good. For this top shock amount, this is going to look kind of strange, but I have seen old dirt bikes I've had that do jumps and weigh more than this thing, as well as, and even current road bikes that weigh a lot more than this thing, use a mount that sticks out from the frame and the shock goes on it. So I'm going to do that theory here. You can use a spacer that you have. I'm going to have one made though that fits in here. But you use a spacer or have one made. You need a bolt from this part here all the way to the end of 80 millimeters. You need a washer. This one's kind of cool looking, but you need something bigger around than that. When you mount a shock like that on a stud, you need a washer that's bigger than the aluminum part. This stuff here can actually pop out. That's how they put it in. So you got to get something bigger than the aluminum part, so if it does try to pop out on you, it'll be held on by the body itself. So we'll put the bolt through, and I'm using a grade 8 bolt, which is grade 12.9, I think, in Chinese. And it's going to look just like that. This is going to thread on here. And that should be strong enough to hold it in place once tightened down with that spacer. And that lines up nicely with the bottom of the swing arm. Here it is with my custom spacer installed. Looks a lot better. Good alignment. And that swing arm will be attached nice and secure like that. If I could hit hard enough to compress that bump stop, then I would have 32 millimeters of travel. The specification said 30 millimeters. That's probably more accurate. But the green line represents 32 millimeters or full compression. It'll be here. So I gotta get the hole to line up with the green line. So I'm gonna take this thing all the way down until it hits the frame. About right there. And get that hole to line up with the green line. So the fully compressed shock should almost hit the frame right there. I can't believe this thing's not going to move either. I'm going to mark it. I may have to end up drilling through that also, just like I did here. That sits pretty high in the back. It definitely gonna need a longer kickstand. So it hits right there on this side first. I think I'm gonna cut away the swing arm. There's a lot of meat there. You could do this with a Dremel. I'm gonna use this bigger tool. It's amazing how much just a little bit of trimming away will get you. So here's how it sits now at full extension. That's a lot better. At full compression, it'll be down another 30 millimeters, but I kind of like that stance right there. It does sit on the kickstand, leans over quite a bit. And you can see I really didn't have to take off that much meat. I don't think it's going to affect the integrity of it any. You can see on this side here how much I took off. It makes a lot of difference. This box is heavy as crap. It's like 87 pounds. Holy cow. The battery will probably be that heavy too. I'm gonna weigh this thing afterwards, I think. I did a video of the before weight when I just got the bike done. It wasn't that heavy. I'm really curious what it weighs after I get this wheel and battery on. It's gonna make the bike heavy. There it is, there's the motor. Now one of the problems I knew I was gonna run into right away is this width right here of the axle. This axle is 16 millimeters wide on the flat part. They also have them 18 millimeters wide. And I think it's the bigger motors that do that. Maybe the littler motors are thinner. So when you look at where it slides into, this part of the swing arm is only 14 millimeters wide. So it's too narrow. I think they make it where you can put the narrowest axle on, and then you have to cut this out with your Dremel or your die grinder to fit the bigger axle. So this whole motor's spinning, and the only thing keeping it from just rolling around on the axle are these things here, really. These are steel. I don't know if I just trust the aluminum on the swing arm. It's probably a lot of power on there. And these slide over this, and they're slotted, so it keeps the axle in place. These fit in here, and they have a little bolt that holds them right there. I'll use a scribe, something sharp like this, to make a line to know what to cut to. I'll just show you with this magic marker. You can see it's only a little bit too wide, so I'd take my line and run in there like that, and I have to cut away this much of this swing arm to make it fit this axle. You can't just cut one side because it has to sit in this steel piece right here, and the steel piece is designed to fit right there and be bolted on there to hold it in place. Keeps it from twisting. This is the same rear brake that goes on a Mad Dog front end. That's your 58 millimeter center. 5/8. And the holes, remember from my brake thing, the weird Mad Dog thing, but you can see it's just a little bit off. The 70 millimeters as they advertise between the holes fits fine. This swing arm is kind of designed for the 3,000 to 5,000 watt hub motors. When you start putting these 20, 25,000 watt hub motors in them, it gets tight between here. They're a little bit wider. So what you end up with is a mount like this. A little flat part of the bolt goes up and down. It's held in place by the things. And the wires, they're pretty tight. They're just kind of bent around to the side and they'll come out. Now, you may not can see this, but inside that swing arm, back in there, it's recessed just like this on both sides. And they give you this little piece to put in there. It's a little aluminum spacer. It goes on the back side on the axle if you have that 3,000 watt motor. But if you got this big motor, that's not even close to fitting on there. So I have to have something to fill in that recessed area back here. I ordered some washers on AliExpress. They're 22 millimeters inside diameter, 30 millimeters outside diameter, but you know, AliExpress, I did not get them. So I've given up on waiting for them. It's been over a month now. I need them. So I went to the local hardware store and got these. They didn't have them thin enough to fit in that little space. So I'm just going to grind the sides off of these and make them fit in there so I can tighten this axle on. Now these square tabs, they do fit the axle because they come with the motor. When you buy your motor, you'll get these two tabs with it. So they're a good fit. But how it's recessed here, it's recessed the very same way on the inside. And that's what we have to fill. But we can't fill it with these because they're too darn big around. So I just need to make them flat on each side a little bit. Alright, so I've got the washers it came with. That's the black ones right here. And this shaft goes from square to round right here. So these washers just go over that round part. Then I've got my custom homemade washers since AliExpress stiffed me. Put those in there. Same on this side, then drop it on down.
Now this tire, it's a bitch to get on. I'll show you a couple things about it. I won't go into a tire changing class, but just a couple of tips on it. A lot of these wheels are scratched up. You'll notice in these videos. They're pretty tough to get on. And there are some guys I've seen online that have had their wheels bent when they go to get them installed by a professional at a tire shop. They'll actually bend these QS motor rims, and that's going to be a disaster because they're expensive. You need to install the tire from this side, the flat side. If you try to install it with the flat side down and the motor side up, then your tire irons don't fit in here good. You end up hitting all this stuff. So have this down. You'll have wires under it. You'll need to put a couple of like 4x4 blocks, something so you won't squish the wires, tall enough that this will be in between the blocks and you have a flat surface to work on. You mount it with this side up, and you can see I scratched it up quite a bit up here. It's pretty tight fit. Remember to get the bead down inside the well, but it's still hard to grab because this lip right here sticks out taller than the bead, so it makes it a difficult tire to install. The brass valve stem in there threads into the aluminum wheel. You try to take the valve cap off, it just pulls the whole brass thing out. It's got a rubber O-ring on it to seal it. So I went ahead and pulled it all the way out. Then I put the brass part back in with Loctite, and I tightened it down as good as I could. There's really nothing to grab. Once you do that, you'll find out your air chuck won't go inside this recessed area, so I put this extension on it. Remember, this motor's going to put you in the big leagues. Line your dot up with your valve stem. It'll help balance your tire. Something to keep in mind about this swing arm. This swing arm is designed for like a 3,000 watt motor, maybe a 5,000 watt motor with very little modification. I'm putting a 20,000 watt motor in here. This motor is way too big for this swing arm, so it's requiring heavy modification. You know, I had to already grind out these channels because this axle is so thick and so big around. But these typically fit in this swing arm if it's like a 3,000 watt motor, 1,500 watt motor. Barely have to do any grinding on a 5,000 watt motor. And that's not the big deal. The important thing is how wide this is. 20,000 watt motor is like 215 to 30 millimeters wide. So like your 5,000 watt motor would be 198 millimeters wide. And you wouldn't have this issue of the brake disc being very close to this. And then the issue of when you put this on, and you see nothing even lines up. There's no room for anything in here. So it all has to be customized. I'm gonna make a plate to bring that over here so I can run this upside down disc like the cool race bikes do. But yeah, so the bigger motor you get, the more you're in deep for modification. And I would say the heavy mods start around 8,000 watts. Now there might be different swing arms that take these things, but the Chinese swing arms they make are more for the mass production stuff, like the smaller motors. I had to special order this motor to get a high-speed motor that was 20,000 watts. It peaks at 40,000, and it has a 1670 RPM. It's a very fast motor. All right, this bracket looks pretty janky still. I'll smooth it out and paint it. And then these bolts, of course, I'll order nice looking hardware like I did here. You know, these cool looking titanium bolts like you see here. The bracket wasn't that hard to make. You can use a plate of steel. I use a plate of aluminum. Just drilled holes in it. The wheel's so wide that the brake caliper is even with the mount. Normally this caliper mounts on this mount. The disc would have to be in about right here for that to work. So with this wide wheel, I had to come over. So you can see the brake disc is still not quite centered in there. That's okay. I've got 2mm washers in here, and I'll put 1mm washers in there. I have to order some. That'll make that all fit better. That's a beautiful brake right there. I mean, it's really nice. I'm gonna put a link to this one in the description. I like this one better. It looks more quality than even that one. And that one's nice too. I ended up getting this one. Then they told me it was out of stock, and so I ordered the other one, and then they ended up sending it after all. I guess it was a miscommunication. So I ended up with two brakes, but I like this one better, but I've already bled that one. I hate to switch them over. When you're running the upside down brake, of course your bleeders are upside down, so you'll never get that brake to bleed. All you do is you take off these two bolts, you flip your brake up to here, you just lay it on top of your disc, and you bleed it. That's the trick. Then once you get it nice and firm, put it back down there, bolt it on. So another issue is this plate is so close to here. This gold plate is so close to the rotor, it was hitting these little blue things that stick up. These kind of free-floating rivets. And it was scratching right against those. It was just barely clearing. So I took this plate off, this gold plate, and I sanded the back side of this down some. Made it a little bit thinner.
And it didn't really matter because they're threaded and the bolts going this way. But yeah, not much room in there. It all seems to fit. You can see how the wires bend over. We'll wrap those around. I'll cover those in the wiring video right now. This should wrap up the swing arm video. I think we're done with it.